Can't sleep? Your mind's still awake? You've come to the right place. This story was created to help you relax, to slow everything down, and gently guide you into deep, peaceful sleep. But first, please put your phone aside. Don't look at the screen. Close your eyes. Take a deep breath in and let it out slowly. Let go of the day. Let your thoughts quiet down. Let this story carry you far away to a calm and comforting place. Just listen and rest. Soon you'll be fast asleep, safe, calm, and at peace. The ancient Egyptians built the Great Pyramid of Giza around 2630 BCE for Pharaoh Khufu, a marvel that still captivates the world today. One of the most incredible parts of this achievement was their ability to move massive stone blocks, many weighing around 2.5 tons or even more, to create this towering structure. To understand how they did this, we need to start with the very first step: quarrying and sourcing the stone. This process was the foundation of the pyramid's construction, and it reveals the Egyptians' remarkable skill, planning, and understanding of their environment. Let's explore how they managed to find, extract, and prepare these enormous stones in a way that made the impossible seem possible. The Great Pyramid was built using millions of stone blocks, mostly limestone and some granite. The limestone came from quarries close to the Giza Plateau, which was a huge advantage because it meant workers didn't have to transport the stones over long distances for most of the pyramid structure. These local quarries were located just a short distance from the construction site, sometimes only a few hundred meters away. The limestone in this area was high quality, strong enough to hold the weight of the pyramid, but soft enough to be worked with the tools the Egyptians had at the time. The proximity of the quarries was a practical choice, as it saved time, energy, and resources. However, for certain parts of the pyramid, like the inner chambers and the outer casing, the Egyptians used granite, which came from much farther away, specifically from Aswan, over 800 kilometers to the south. Transporting granite was a much bigger challenge, but we'll focus on that later. For now, let's look at how the Egyptians got the limestone blocks out of the ground and ready for the pyramid. Quarrying stone in ancient Egypt was no small task. The workers didn't have modern machinery or explosives, so they relied on simple but clever tools and techniques. Their main tools were made of copper, which might sound surprising because copper is a soft metal compared to stone. But the Egyptians were skilled at using what they had. They used copper chisels, picks, and drills, along with harder stones like dolerite, to chip away at the limestone. Dolerite is a tough volcanic rock that was perfect for pounding and breaking softer stones like limestone. Workers would hammer dolerite stones into the limestone to create cracks or to shape the blocks. This process required patience and precision, as they had to follow the natural layers and weaknesses in the rock to make their work easier. To cut the limestone blocks, workers first marked out the shape they wanted on the surface of the quarry. They would use tools to score lines into the rock, creating a guide for where the block would be separated. This was important because the blocks needed to be roughly uniform in size to fit together properly in the pyramid. The standard limestone blocks for the Great Pyramid were about 1 meter by 1 meter by 1.4 meters, weighing around 2.5 tons each. Getting the stone to break cleanly along these lines was a challenge, so the Egyptians used a combination of methods. One common technique was to drive wooden wedges into the cracks they had made. They would then soak these wedges with water. As the wood absorbed the water, it expanded, putting pressure on the surrounding stone and causing it to split along the desired line. This method took advantage of simple physics, showing how the Egyptians understood the properties of materials like wood and stone. Another technique might have involved the heating and cooling the stone to weaken it. Workers could have built fires on the surface of the rock to heat it up, then poured cold water over it to create thermal stress, which would cause the stone to crack. While there's no direct evidence that this method was used for the Great Pyramid, similar techniques have been documented in other ancient quarrying practices, and it's possible the Egyptians experimented with this approach. These methods, whether using wedges or thermal shock, show how the Egyptians worked with the natural properties of the stone rather than fighting against them. They didn't have the technology we have today, but they were masters at using their environment to their advantage. Once the blocks were separated from the quarry, workers had to smooth and shape them to make sure they were the right size and fit for the pyramid. This was done by chiseling and grinding the surfaces with copper tools and abrasive materials like sand. Sand, when rubbed against stone with a hard tool, could act like sandpaper, slowly wearing down rough edges. This process was labor-intensive and required a lot of time and effort, but it ensured that the blocks would fit together tightly, which was crucial for the pyramid's stability. The precision of the blocks is one of the reasons the Great Pyramid has stood for over 4,500 years. Some of the stones were so well cut that you can barely slip a piece of paper between them, even today. While limestone was the main material for the pyramid's core, the granite used for parts like the king's chamber and the outer casing stones was a different story. Granite is much harder than limestone, so quarrying it was even more difficult. The granite quarries in Aswan were located along the Nile River, which was both a challenge and an opportunity. The Egyptians couldn't just drag these heavy stones across hundreds of kilometers of desert, so they relied on the river to transport them. During the Nile's annual flooding season, when water levels were high, workers could load the granite blocks onto large wooden barges and float them down the river toward Giza. This was a slow and careful process, as the barges had to be strong enough to carry stones weighing up to 50 tons or more in some cases. To make this possible, the Egyptians likely built canals or temporary waterways to bring the stones as close as possible to the construction site. Evidence of such canals has been found near the Giza Plateau, suggesting that the Egyptians engineered their landscape to support the pyramid's construction. Back at the limestone quarries, the process of extracting the blocks was a team effort. Workers were organized into groups, each with specific roles. Some would cut and shape the stone, while others would prepare the quarry surface or clear away debris. Overseers and architects likely supervised the work, ensuring that the blocks met the pyramid's requirements. The scale of the operation was enormous. Some estimates suggest that the Great Pyramid required over 2 million blocks. To produce this many blocks, the Egyptians had to have a well-coordinated system, with workers rotating shifts and supplies like food and tools constantly flowing to the site. Archaeological evidence, like workers' villages found near Giza, shows that these laborers were well cared for, with access to bread, beer, and meat, which was a sign of their importance to the project. The quarrying process also required a deep understanding of the land. The Egyptians chose their quarry sites carefully, looking for areas where the stone was not only high quality, but also accessible. They studied the natural layers of the rock to find the easiest places to cut, and they planned their work to minimize waste. This careful planning extended to how they managed their resources. For example, the debris and smaller stones left over from quarrying were often used to build ramps or fill in parts of the pyramid's foundation, ensuring that nothing went to waste. The quarrying and sourcing of the stone was just the beginning, but it set the stage for everything that followed. The Egyptians' ability to extract millions of blocks with simple tools, transport granite across hundreds of kilometers, and organize their workforce so efficiently shows their incredible ingenuity. They didn't have cranes or trucks, but they had knowledge, teamwork, and a deep connection to their environment. This first step in building the Great Pyramid, finding and preparing the stone, was a massive undertaking that required patience, skill, and determination. It's a reminder that the ancient Egyptians were not only builders, but also problem solvers, capable of turning their vision of a monument for their pharaoh into reality, one carefully quarried block at a time. The process of building the Great Pyramid of Giza was an incredible feat, and after the stones were quarried and prepared, the next critical step was organizing the people who made it all happen. The labor force and the way they were managed played a huge role in turning piles of stone into one of the world's most enduring monuments. Constructing the pyramid required not just physical strength, but also careful planning, teamwork, and a system that kept thousands of workers moving in the same direction. Let's explore how the ancient Egyptians organized their labor force, who these workers were, and how their efforts were coordinated to move and place millions of 2.5-ton stone blocks. The Great Pyramid, built around 2630 BCE for Pharaoh Khufu, needed an enormous number of workers. Estimates vary, but historians and archaeologists believe that tens of thousands of people were involved over the 10 to 20 years it took to complete the pyramid. Some older stories, like those from the Greek historian Herodotus, writing centuries later, suggested that the pyramids were built by slaves forced to work under harsh conditions. However, modern discoveries have painted a very different picture. Evidence from archaeological sites near Giza, including workers' villages, tombs, and written records, shows that the labor force was likely made up of skilled workers, farmers, and craftsmen who were well treated and motivated to contribute to this massive project. These findings have changed how we view the people who built the pyramid, showing they were not slaves, but valued members of society. The workforce was a mix of different types of workers, each with specific roles. At the core were skilled laborers, such as stonecutters, masons and carpenters, who had the expertise to shape and place the stones with precision. These skilled workers were likely permanent employees or specialists who worked on construction projects year-round. They knew how to use tools like copper chisels, wooden levers, and measuring devices to ensure the blocks fit perfectly. Their expertise was crucial, as the pyramid's design required stones to be placed with incredible accuracy, sometimes so tight that the gaps between them are barely visible today. Alongside these skilled workers were thousands of less specialized laborers. Many of these were farmers who came to work on the pyramid during the agricultural off-season, particularly during the Nile's annual flooding period. When the river flooded the fields between July and November, farming was impossible. So many farmers traveled to Giza to join the construction effort. This seasonal workforce was a smart way to make use of people who were available and willing to work. It also meant that the project didn't disrupt Egypt's food production, as these workers could return to their fields when the floods receded. This system shows how the Egyptians planned their labor force around the rhythms of their environment, making the most of their resources. The workers were organized into teams, likely groups of 24 to 30 people, each responsible for specific tasks like hauling stones, building ramps, or setting blocks in place. These teams were further grouped into larger units, sometimes called files, a term borrowed from the Egyptian word for a crew or clan. Each file might have had hundreds of workers, and they were divided into smaller squads with names like Friends of Khufu or Enduring Ones, as found in inscriptions near the pyramid. These names suggest the sense of pride and identity among the workers, as if they saw themselves as part of something meaningful. The teams worked together like a well-oiled machine, with each group handling a piece of the larger process, from moving stones to the site to lifting them into position. Managing such a large workforce required careful organization. Overseers and supervisors played a key role in keeping everything on track. These leaders were likely educated men who could read, write, and understand the architectural plans drawn up by the pyramid's designers. They directed the teams, ensured tools and supplies were available, and solved problems that came up during construction. Written records from the time, such as those found in the Wadi al-Jarf papyri, describe how supplies like food and tools were delivered to the workers. These documents show that the Egyptians kept detailed logs of their resources, tracking everything from the number of stones moved to the amount of bread baked for the laborers. This level of record-keeping highlights their ability to manage a project of this scale with precision. The workers were not just thrown into the job without support. Archaeological discoveries near Giza, like the remains of a workers' village, reveal that the laborers lived in a well-organized settlement close to the pyramid site. This village had barracks, bakeries, breweries, and even medical facilities. The presence of bakeries and breweries is especially telling, as bread and beer were staples of the Egyptian diet. Workers were fed hearty meals, including meat, which was a luxury in ancient Egypt. Animal bones found at the site show that cattle, sheep, and goats were slaughtered to feed the workforce, suggesting that the workers were valued and well cared for. Medical care was also available, as evidenced by skeletons showing signs of treated injuries, like broken bones that had been set and healed. This level of care indicates that the Egyptians invested in keeping their workers healthy and productive. Workers' living conditions were better than what many might imagine for such a massive construction project. The village was designed to house thousands of people, with separate areas for skilled workers and seasonal laborers. The skilled workers, like masons and architects, likely had better accommodations, while the seasonal workers lived in simpler barracks. Despite these differences, the overall setup shows that the Egyptians went to great lengths to keep their workforce strong and motivated. Some workers even had their own tombs near the pyramid, a sign of their importance and status. These tombs, though much smaller than the pharaohs, were decorated with inscriptions and offerings, suggesting that the workers took pride in their role in building the pyramid. What motivated these workers to take on such a grueling task? For many, it was likely a combination of practical and spiritual reasons. Practically, working on the pyramid provided food, shelter, and a sense of purpose during the agricultural off-season. Spiritually, the pyramid was more than just a tomb. It was a symbol of Egypt's strength and the pharaoh's divine connection to the gods. The Egyptians believed that building the pyramid helped ensure the pharaoh's journey to the afterlife, which in turn maintained cosmic order and protected the land. This belief likely gave the workers a sense of duty and pride, as their work contributed to something eternal. Some inscriptions even suggest that workers saw their labor as a way to honor their gods and their king. The organization of the labor force wasn't just about getting the job done. It was about creating a system where everyone had a role, from the person chiseling the stone to the overseer checking the measurements. This system allowed the Egyptians to coordinate thousands of people over many years without chaos. They didn't have modern communication tools, but they used their knowledge of teamwork, planning, and resource management to keep the project moving forward. The fact that the Great Pyramid was completed in just a couple of decades shows how effective this system was. Each worker, whether hauling a stone or baking bread, was a small but essential part of the bigger picture. The labor force and its organization were the backbone of the pyramid's construction. Without the dedication of these workers, the ingenuity of their supervisors, and the careful planning behind it all, the Great Pyramid would never have risen from the desert. The Egyptians' ability to bring together skilled craftsmen, seasonal laborers, and support staff into a unified effort shows their strength as a society. They didn't just build a monument, they created a system that turned their vision into reality, one block at a time. This teamwork and organization set the stage for the next steps, like moving the stones and placing them in the pyramid, which we'll explore later. For now, it's clear that the people who built the Great Pyramid were as remarkable as the structure itself. With the stones quarried and the workers organized, the next critical step in building the Great Pyramid of Giza was moving the massive 2.5-ton limestone blocks to the construction site and up the growing structure. This was no easy task, as the Egyptians didn't have modern machines like cranes or trucks. Instead, they relied on clever techniques, simple tools, and their deep understanding of how to make heavy loads easier to handle. One of the most important methods they used involved sledges and ramps, which allowed them to transport and lift the stones with remarkable efficiency. Let's explore how the ancient Egyptians used these tools to move millions of blocks and build a pyramid that has stood for over 4,500 years. The idea of moving a 2.5-ton stone block might seem impossible without modern equipment, but the Egyptians found ways to make it manageable. The primary tool for transporting stones across the ground was the sledge, a simple wooden platform that worked like a giant sled. Workers would place a stone block on the sledge, which had runners on the bottom to help it slide. Teams of workers, likely 10 to 20 strong men, would then pull the sledge using ropes made from materials like papyrus or palm fiber. These ropes were strong enough to handle the weight and allowed the workers to coordinate their efforts, pulling together in rhythm to move the heavy load. The sledges were sturdy but basic, designed to spread the weight of the stone and reduce the strain on the workers. Dragging a sledge loaded with a 2.5-ton block across dry sand would have been incredibly difficult because of the friction between the sledge and the ground. The Egyptians, however, figured out a brilliant way to reduce this friction. Modern experiments, like those conducted by archaeologists in the 2010s, have shown that wetting the sand in front of the sledge made it much easier to pull. When sand is slightly wet, it becomes firmer and less likely to shift under the sledge, almost like a smooth track. This discovery was a game changer, as it meant fewer workers were needed to move each block. For a 2.5-ton stone, a team of 10 to 15 workers could likely pull the sledge across wet sand, compared to many more on dry sand. This technique shows how the Egyptians used their environment, sand and water, to solve practical problems. To prepare the ground for moving the stones, workers likely created smooth paths from the quarry to the pyramid site. The limestone quarries were close to the Giza plateau, sometimes just a few hundred meters away, so the stones didn't have to travel far. Workers would clear debris, level the ground, and possibly lay down a layer of clay or gypsum to make a slick surface for the sledges. In some cases, they might have used logs as rollers under the sledge to reduce friction even further, especially on flat ground. These rollers would act like primitive wheels, allowing the sledge to glide more easily. While there's no direct evidence of rollers being used at Giza, similar techniques have been found in other ancient Egyptian sites, and it's reasonable to think the pyramid builders might have tried this method. Once the stones reached the base of the pyramid, the challenge became even greater: how to lift them to the higher levels as the pyramid grew taller. This is where ramps came into play. Ramps were like sloped roads made of mud brick, limestone chips, or gypsum, built to allow workers to drag the sledges upward. The Egyptians likely used different types of ramps depending on the stage of construction and the terrain. One common design was a straight ramp that extended out from the pyramid's base, sloping gently upward. This type of ramp was simple to build, but took up a lot of space, and required a lot of material as the pyramid got taller. To address this, the Egyptians might have used a zigzagging ramp that switched back and forth along one side of the pyramid, like a mountain road. Another possibility was an encircling ramp that wrapped around the pyramid, spiraling upward as the structure grew. Archaeological evidence supports the use of ramps. In 2018, researchers found a ramp system at the Shatnub Quarry, another ancient Egyptian site, with post holes on either side. These post holes suggest that workers used ropes and posts to stabilize the sledges or guide them up the ramp. While this ramp wasn't at Giza, it shows that the Egyptians had experience building and using ramps for heavy stones. For the Great Pyramid, the ramps were likely temporary structures, dismantled or reused as fill once the pyramid was complete. This would explain why we don't see massive ramps still standing at Giza today. The ramps were probably built in stages, extended or modified as the pyramid rose higher. Building and maintaining the ramps was a huge task in itself. The ramps had to be strong enough to support the weight of the stones, sledges, and workers, and they needed a gentle enough slope to make pulling possible. Engineers estimate that the slope of the ramps was likely around 10 degrees or less, which would allow workers to haul the stones without losing control. To create these ramps, workers used materials left over from the quarrying process, like small limestone chips and mud brick, which were easy to shape and plentiful. Teams of workers would have been dedicated to building and repairing the ramps, ensuring they remained stable and smooth throughout the construction. The process of moving a stone up a ramp was a team effort. A group of workers would pull the sledge from the front, while others might push from behind or steady the load with ropes. In some cases, the Egyptians might have used counterweights to help lift the stones. For example, they could have attached ropes to a heavy object like another stone and let it slide down the opposite side of the ramp to help pull the sledge upward. This technique would have reduced the number of workers needed and made the process more efficient. While there's no definitive proof of counterweights at Giza, similar systems have been suggested for other ancient Egyptian projects, and it fits with their knack for finding practical solutions. The sledges and ramps worked together as a system, allowing the Egyptians to move and lift stones with surprising efficiency. Each sledge was likely reused many times, hauled back down the ramp after delivering a stone to be loaded with another. Workers would have developed a rhythm, with teams coordinating their efforts to keep the stones moving steadily. The ramps, meanwhile, were adjusted as needed, extended or reshaped to reach higher levels of the pyramid. This system required not just physical strength, but also careful planning and communication. Overseers would have directed the teams, ensuring that the right number of workers, sledges, and ropes were in place at the right time. The use of sledges and ramps shows how the Egyptians turned a seemingly impossible task into something achievable. They didn't need complex machines because they understood how to work with simple tools and their environment. Wetting the sand, building sturdy ramps, and organizing teams of workers allowed them to move millions of stones, one by one, to create the Great Pyramid. This process was slow and labor-intensive, but it was effective. The fact that the pyramid was completed in about 10 to 20 years, with an estimated 2.3 million blocks, is a testament to the Egyptians' ingenuity and determination. The sledges and ramps were just one part of the larger effort, but they were crucial to getting the stones from the quarry to their final place in the pyramid. This step relied on the teamwork and organization of the workers, as well as the careful planning of the architects and overseers. It's a reminder that the Great Pyramid wasn't just a pile of stones. It was the result of countless small, smart decisions that added up to something extraordinary. The next steps, like using levers and other tools to position the stones, built on this foundation, bringing the pyramid closer to completion with each block. With the stones quarried, workers organized, and sledges and ramps in place to move the massive 2.5-ton blocks, the ancient Egyptians faced the next challenge: positioning these stones with precision to build the Great Pyramid of Giza. This step required not just moving the blocks to the right spot, but also lifting, turning, and setting them perfectly to create a stable, towering structure. To do this, the Egyptians relied on leverage and simple machines, tools and techniques that used basic principles of physics to make heavy work easier. These methods show how clever and resourceful the Egyptians were, turning their limited technology into solutions that helped them achieve one of the greatest engineering feats in history. Let's explore how they used these tools to handle the stones and build the pyramid with such accuracy. The Great Pyramid, built around 2630 BCE for Pharaoh Khufu, is famous for its precision. The stones are so tightly fitted that, in many cases, you can barely slide a piece of paper between them. Achieving this level of accuracy with 2.5-ton blocks, and sometimes much heavier granite ones, was no small task. The Egyptians didn't have cranes or hydraulic lifts, but they had a deep understanding of how to use simple tools like levers, rollers, and pivot systems. These tools, combined with their knowledge of balance and force, allowed them to lift, shift, and place the stones exactly where they needed to go. This process was slow and careful, but it was essential for creating a structure that has stood for over 4,500 years. One of the most important tools was the lever, a simple device that uses a rigid bar and a pivot point called a fulcrum to lift or move heavy objects. Imagine a long wooden beam balanced on a small rock. By pushing down on one end of the beam, you can lift a heavy weight on the other end with less effort. The Egyptians likely used levers made of strong wood, perhaps reinforced with ropes or metal tips, to lift stones slightly off the ground or nudge them into position. For example, if a stone needed to be raised a few inches to slide onto a sledge or fit into place on the pyramid, workers could slip a lever underneath and press down to lift it. By working together, a small team could use several levers to gradually raise or shift a block, making small adjustments until it was perfectly aligned. Levers were especially useful when the stones reached the top of a ramp and needed to be placed on the pyramid's growing structure. The ramps, as we discussed earlier, brought the stones to the right height, but the final positioning required precision. Workers would use levers to tilt or rotate the stone, inching it into its spot. This process was delicate because the blocks had to fit snugly against their neighbors to ensure the pyramid's stability. The Egyptians' ability to use levers effectively shows their practical understanding of physics, even if they didn't have the scientific terms we use today. They knew that a long lever gave them more power to lift a heavy weight, and they used this knowledge to make their work easier. Another tool that likely helped was the roller, a round piece of wood or stone that acted like a primitive wheel. Rollers could be placed under a stone or sledge to help it move more smoothly across a flat surface. Unlike sledges which slid across the ground, rollers reduced friction by allowing the stone to roll forward. Workers might have laid out a series of rollers like logs in a line, moving the stone from one to the next. As the stone rolled off one roller, they would pick it up and place it at the front of the line, creating a continuous path. This method would have been especially useful on the flat top of the pyramid's working surface, where stones needed to be moved short distances into their final positions. While there's no direct evidence of rollers at the Great Pyramid, similar techniques were used in later Egyptian projects, and it's likely the pyramid builders experimented with them. Pivot systems were another clever way to position stones. A pivot system uses a rounded base or pivot point to rotate a heavy object. For example, workers might have placed a stone on a curved wooden or stone base, allowing them to turn it by pushing or pulling. This would have been helpful for aligning stones that needed to face a specific direction or fit into a tight corner. By rocking the stone on the pivot, workers could make small adjustments without needing to lift the entire block. These systems were simple but effective, showing how the Egyptians found ways to work smarter, not just harder. The combination of levers, rollers, and pivot systems allowed the Egyptians to handle the stones with precision, but these tools also required teamwork and coordination. A single worker couldn't operate a lever or roller system alone. It took a group working together, each person with a specific role. Some would push or pull the levers. Others would place rollers or stabilize the stone, and overseers would guide the process to ensure the stone ended up exactly where it needed to be. This teamwork was critical because even a small mistake could throw off the pyramid's alignment or weaken its structure. The Egyptians' ability to coordinate these efforts shows their skill in managing complex tasks with limited technology. In addition to these tools, the Egyptians likely used ropes to help control the stones. Ropes made from papyrus or other plant fibers were strong and flexible, allowing workers to guide the stones as they were lifted or moved. For example, ropes could be tied around a stone to keep it steady while levers lifted it, or to pull it into place after it was raised. Ropes might also have been used with pulleys or counterweights in some cases, though evidence for pulleys at Giza is limited. A counterweight system, where a heavy object was used to balance or lift a stone, could have made it easier to raise blocks to higher levels. For instance, workers might have attached ropes to a stone on one side of a ramp and a heavy weight on the other, letting the weight slide down to help pull the stone up. This idea is speculative, but fits with the Egyptians' creative approach to solving problems. The precision of the Great Pyramid's construction is one of its most impressive features, and levers, rollers, and pivot systems played a big role in making that possible. The outer casing stones, made of polished Tura limestone, were cut so precisely that they created a smooth, shining surface. The inner blocks, while rougher, still had to fit tightly to ensure the pyramid's stability. To achieve this, workers likely used measuring tools like plumb bobs and squares to check the alignment of each stone. A plumb bob, a weight hanging from a string, could show if a stone was perfectly vertical, while a square could ensure right angles. These tools, combined with levers and rollers, allowed the workers to fine-tune the position of each block, creating a structure that was both strong and beautiful. The use of these simple machines also shows how the Egyptians adapted their methods as the pyramid grew. Early in the construction, when the pyramid was low, workers could move stones directly from the ground to their place. But as the pyramid rose higher, the ramps became longer, and the stones needed to be lifted to greater heights. Levers and rollers were versatile enough to work at different stages, whether the workers were placing stones on the base or high up on the structure. This flexibility was key to keeping the project moving forward, even as the challenges grew. The reliance on leverage and simple machines highlights the Egyptians' ingenuity. They didn't need complex technology because they understood how to use basic tools to achieve big results. Each lever, roller, or pivot system was a small but crucial part of the process, turning the back-breaking work of moving 2.5-ton blocks into something manageable. The workers' skill, combined with the guidance of architects and overseers, ensured that every stone was placed with care. This step built on the earlier efforts of quarrying, organizing workers, and using sledges and ramps, bringing the pyramid closer to completion. The next steps, like transporting granite or building higher ramps, would rely on these same principles of teamwork and clever engineering, showing how every part of the process worked together to create the Great Pyramid. With the stones quarried, workers organized, sledges and ramps used to move the blocks, and levers employed to position them. The next piece of the puzzle in building the Great Pyramid of Giza was getting the heavier granite stones to the site. While most of the pyramid was made of limestone from nearby quarries, certain parts, like the king's chamber and some outer casing stones, used granite, which came from Aswan, over 800 kilometers away. Transporting these massive stones, some weighing up to 50 tons, across such a vast distance without modern vehicles, was a huge challenge. The ancient Egyptians relied on water transport, using the Nile River and their knowledge of its seasonal patterns. To make this possible, let's explore how they managed to move these heavy granite blocks over hundreds of kilometers to the Giza Plateau, revealing their remarkable ingenuity and resourcefulness. The Nile River was the lifeblood of ancient Egypt, providing water, food, and a natural highway for transportation. The Egyptians understood the river's rhythms, especially its annual flooding season between July and November, when heavy rains in the Ethiopian highlands caused the Nile to swell. During this time, the river became wider and deeper, making it ideal for moving large, heavy loads. The granite quarries in Aswan, located along the Nile's banks, gave the Egyptians a strategic advantage. They could load the granite blocks onto boats and float them downstream to Giza, avoiding the grueling task of dragging them across the desert. This water transport system was a key part of their success, allowing them to move stones that would have been nearly impossible to haul over land. The boats used for this task were not small canoes, but large, sturdy vessels designed to carry heavy loads. These were likely wooden barges, built from materials like cedar, imported from Lebanon or local acacia wood. The barges had flat bottoms and wide hulls to stay stable under the weight of the granite blocks. Some estimates suggest these boats could carry stones weighing 50 tons or more, which shows how well engineered they were. Building these boats was a skilled craft, requiring carpenters and shipwrights who knew how to construct vessels strong enough for the job. The boats also needed to be large enough to hold multiple stones or one massive block, with space for rowers or sailors to navigate the river. Loading the granite blocks onto the boats was a careful process. At the Aswan quarries, workers would first cut the granite using methods like those for limestone, though granite was much harder. They used dolerite hammers and copper tools to chip away at the stone, often following natural cracks to make the work easier. Once a block was shaped, workers likely dragged it to the riverbank using sledges similar to those used at Giza. To get the stone onto the boat, they might have built temporary ramps or platforms leading to the water's edge. These ramps allowed workers to slide the stone onto the barge, possibly using rollers or wet sand to reduce friction, just as they did for limestone blocks. The process required teamwork and precision to ensure the heavy stone didn't tip the boat or damage it. Once the granite blocks were loaded, the boats set off down the Nile. The journey from Aswan to Giza was mostly downstream, which made it easier because the river's current helped carry the boats along. Workers likely used oars or sails to steer and control the speed, ensuring the boats stayed on course. The flooding season was ideal because the high water levels allowed the boats to travel closer to the Giza Plateau, reducing the distance the stones needed to be moved over land. The Egyptians may have also dug canals or temporary waterways to bring the boats even closer to the pyramid site. Archaeological evidence near Giza suggests the existence of such canals, which would have connected the Nile to a harbor or docking area near the construction site. These canals were likely temporary, filled in after the pyramid was finished, which explains why they're not visible today. The journey down the Nile was not without challenges. The river could be unpredictable, with currents, winds, or shallow areas posing risks. The weight of the granite blocks made the boats harder to maneuver, so the crews had to be skilled and experienced. They likely traveled in groups with multiple boats carrying stones or supplies to make the process more efficient. Overseers would have coordinated the effort, ensuring the boats arrived at the right time and place. The Wadi al-Jarf papyri, discovered in 2013, provide rare insight into this process. These ancient documents describe the logistics of transporting stone for the pyramid, including details about boats and their crews. One logbook written by an overseer named Merer mentions delivering stones from Dura, a limestone quarry, to Giza, suggesting that similar methods were used for granite. When the boats reached Giza, the next step was unloading the granite blocks and moving them to the pyramid site. This was another complex task, as the stones had to be carefully removed from the boats without damaging them or the vessels. Workers likely used ramps or levers to slide the stones off the boats and onto the shore. From there, they would drag the stones to the pyramid using sledges, just like the limestone blocks. The distance from the river to the pyramid was short, perhaps a kilometer or less thanks to the canals, but it still required effort. The granite blocks were much heavier than the average limestone block, so more workers or stronger sledges may have been needed. Wetting the sand or using rollers could have helped make this final leg of the journey smoother. The use of water transport for granite shows how the Egyptians planned around their environment. They timed the transport to coincide with the Nile's flood season, when the river was at its most navigable. They also built infrastructure like canals to bring the stones as close as possible to the site, reducing the need for overland transport. This careful planning was essential because granite was not just heavier, but also more valuable than limestone. The Egyptians used it sparingly, reserving it for important parts of the pyramid, like the king's chamber, where its strength was needed to support the massive weight above. The precision of these granite blocks, some cut to fit within millimeters, shows the care taken at every step, from quarrying to transport to placement. The workers involved in water transport were likely a mix of sailors, laborers, and overseers. The sailors needed to know the Nile's currents and how to handle the heavy boats, while laborers handled loading and unloading. Overseers kept the operation running smoothly, tracking the stones and ensuring they arrived on time. These workers were part of the larger workforce that built the pyramid, and like the quarry workers and ramp builders, they were well fed and housed. The workers' village near Giza, with its bakeries and breweries, supported everyone involved, from those dragging stones to those sailing them down the river. This shows how interconnected the entire process was, with each group relying on the others to keep the project moving forward. Water transport was a critical part of building the Great Pyramid, especially for the granite blocks that gave the structure its strength and grandeur. Without the Nile, moving these stones from Aswan would have been nearly impossible. The Egyptians' ability to harness the river's power, build sturdy boats, and create canals shows their deep understanding of their environment and their skill in logistics. This step built on the earlier efforts of quarrying and organizing workers, and it set the stage for the ramps and levers that would lift the stones into place. The journey of the granite blocks from the quarries of Aswan to the heart of the pyramid is a testament to the Egyptians' determination and ingenuity, turning a daunting task into a triumph of human effort. With the granite stones transported from Aswan, the limestone blocks quarried nearby, the workers organized, and tools like sledges and levers ready, The ancient Egyptians faced the challenge of building the Great Pyramid of Giza to its full height. Moving millions of 2.5-ton blocks up to higher levels required more than just strength. It demanded a carefully planned system to lift and place the stones as the pyramid grew taller. This is where ramp systems and construction logistics came into play. Ramps were the backbone of getting stones to the upper levels, and the logistics of managing materials, workers, and schedules ensured the project stayed on track. Let's explore how the Egyptians designed and used ramps, along with their clever approach to organizing the construction process, to create one of the world's most enduring monuments. The Great Pyramid, built around 26 or 30 BCE for Pharaoh Khufu, stands about 146 meters tall and contains an estimated 2.3 million stone blocks. To stack these blocks layer by layer, the Egyptians needed a way to lift them to higher levels as the pyramid rose. Dragging stones across flat ground was one thing, but hauling them up a growing structure was another. Ramps were the solution, acting like sloped roads that allowed workers to pull stones on sledges to the working surface of the pyramid. These ramps were not simple piles of dirt, but carefully engineered structures built to support heavy loads and adapt to the pyramid's changing shape. The logistics behind the ramps, planning, building, and maintaining them, show the Egyptians' skill in managing a massive project with limited technology. The ramps were likely made of materials like mud brick, limestone chips, and gypsum, which were plentiful and easy to work with. Mud brick was made by mixing Nile mud with a straw and drying it in the sun, creating strong, lightweight bricks. Limestone chips, left over from quarrying, were used as fill to add bulk to the ramps. Gypsum, a soft mineral, could be mixed with water to form a plaster-like material that helped hold the ramps together. These materials were chosen because they were readily available and could be shaped into stable slopes. The ramps had to be wide enough for teams of workers to pull sledges and strong enough to support the weight of the stones, which ranged from 2.5 tons for limestone to 50 tons or more for granite. There were likely several types of ramps used during the pyramid's construction, each suited to different stages or needs. One possible design was a straight ramp that extended out from one side of the pyramid, sloping upward to reach the working level. This type of ramp was simple to build in the early stages when the pyramid was low, but as it grew taller, a straight ramp would have become too long and required too much material. To solve this, the Egyptians might have used a zigzagging ramp, which switched back and forth along one face of the pyramid, like a mountain trail. This design saved space and materials while still reaching the higher levels. Another idea was an encircling ramp that wrapped around the entire pyramid, spiraling upward like a coiled path. This type of ramp could reach all sides of the pyramid, but would have been complex to build and maintain. Archaeological evidence supports the use of ramps. In 2018, a ramp system was discovered at the Hatnub Quarry, another ancient Egyptian site, with post holes along the sides. These post holes suggest that workers used ropes and posts to guide or stabilize sledges as they moved up the ramp. While this ramp wasn't at Giza, It shows that the Egyptians had experience building ramps for heavy stones, and a similar system likely existed at the Great Pyramid. Some researchers believe the Egyptians used a combination of ramp types, starting with a straight ramp for the lower levels and switching to zigzagging or encircling ramps as the pyramid grew. These ramps were likely temporary, dismantled or reused as fill once the pyramid was complete, which explains why no large ramps remain at Giza today. Building the ramps was a major task that required as much effort as moving the stones themselves. Workers dedicated to ramp construction would have hauled mud brick, limestone chips, and gypsum to the site, shaping them into smooth, stable slopes. The ramps needed a gentle slope, likely around 8 to 10 degrees, to allow workers to pull the heavy sledges without losing control. A steeper slope would have been too difficult, while a flatter slope would have taken too much space and material. Engineers likely used simple tools like plumb bobs and sighting instruments to measure the slope and ensure it was consistent. Maintaining the ramps was also important, as the constant movement of sledges and workers could wear down the surface. Teams would have repaired damaged sections, adding fresh material to keep the ramps functional. The logistics of the construction process went beyond just building ramps. The Egyptians had to coordinate the flow of stones, workers, and supplies to keep the project moving smoothly. The Great Pyramid was built in about 10 to 20 years, which means workers placed roughly 800 stones per day, assuming they worked year-round. This pace required a steady supply of stones from the quarries, boats arriving with granite from Aswan, and enough sledges, ropes, and tools to keep the teams busy. Overseers played a key role in managing this process, tracking the number of stones delivered, assigning workers to tasks, and ensuring ramps were ready for use. Ancient records like the Wadi al-Jarf papyri show that the Egyptians kept detailed logs of their operations, including the movement of stones and supplies. These records highlight their ability to plan and organize on a massive scale. The workers moving stones up the ramps were organized into teams, just like those in the quarries or on the boats. A typical team might have included 10 to 20 workers pulling a sledge, with others guiding the stone or stabilizing it with ropes. For heavier granite blocks, more workers or additional equipment, like counterweights, might have been needed. A counterweight system could involve attaching ropes to a heavy object, like another stone, and letting it slide down the opposite side of the ramp to help pull the sledge upward. This method would have reduced the number of workers needed and made lifting easier. While evidence for counterweights at Giza is speculative, it fits with the Egyptians' practical approach to problem solving. The ramps and logistics also had to adapt as the pyramid grew. In the early stages, when the pyramid was low, the ramps were shorter and simpler. As the structure rose, the ramps needed to be extended or rebuilt to reach higher levels. This required careful planning to ensure the ramps didn't interfere with the pyramid's construction or take up too much space. Some researchers suggest that internal ramps, sloped passages built inside the pyramid structure, might have been used for the upper levels. These internal ramps would have been covered as the pyramid was completed, leaving no trace. While this idea is debated, it shows how the Egyptians might have combined different ramp designs to meet the project's needs. The workers' village near Giza supported the ramp building and logistical efforts. This settlement provided food, tools, and shelter for the thousands of workers involved. Bakeries and breweries produced bread and beer, the staples of the Egyptian diet, while storehouses held ropes, wood, and other supplies. The village was a hub of activity, with workers coming and going, supplies being distributed, and overseers planning the next steps. This level of organization ensured that the construction never stopped, even as the challenges grew with the pyramid's height. The ramp systems and construction logistics were a testament to the Egyptians' ability to think big and plan carefully. They didn't just build ramps. They created a system that kept stones, workers, and materials moving in harmony. Each ramp was a temporary but vital part of the process, enabling the workers to lift millions of blocks to their final places. The logistics behind it, coordinating quarries, boats, ramps, and teams, showed the Egyptians' mastery of large-scale projects. This step built on the earlier efforts of quarrying, organizing workers, and transporting stones, bringing the pyramid closer to its final form. The next piece, the cultural and religious motivation behind the work, would reveal why the Egyptians poured so much effort into this monumental task. With the stones quarried, workers organized, sledges and ramps used to move blocks, levers, and simple machines employed to position them, granite transported via the Nile, and ramp systems carefully managed, the final piece of the puzzle in building. The Great Pyramid of Giza was the driving force behind it all. The cultural and religious motivation of the ancient Egyptians. This motivation was not just about completing a massive construction project, but about fulfilling a deeper purpose tied to their beliefs, society, and way of life. The Great Pyramid, built around 2630 BCE for Pharaoh Khufu, was more than a tomb. It was a symbol of divine order, a connection between the earthly and spiritual worlds. Let's explore how the Egyptians' culture and religion inspired the workers, leaders, and society to dedicate years of effort to this extraordinary monument. In ancient Egypt, religion was at the heart of everything. The Egyptians believed their world was governed by a complex system of gods, spirits, and cosmic forces that kept life in balance. This balance, called Ma'at, was the principle of harmony, truth, and order that guided their society. The pharaoh was seen as a living god, a bridge between the people and the divine. His role was to maintain Ma'at on earth, ensuring the gods were pleased. The Nile flooded predictably, and Egypt prospered. When a pharaoh died, his journey to the afterlife was crucial, as it was believed he would join the gods and continue to protect the land. The Great Pyramid was designed to help Pharaoh Khufu make this journey, serving as both a tomb and a spiritual gateway. This belief gave the pyramid a sacred purpose, motivating everyone involved to see their work as part of a greater mission. For the workers, building the pyramid was not just a job, but a way to serve their gods and their king. The Egyptians believed that contributing to the pharaoh's tomb was a holy act, one that could bring blessings in this life and the next. Workers, whether skilled masons or seasonal farmers, likely felt a sense of pride and duty in their labor. Inscriptions found near Giza, such as those naming work crews Friends of Khufu or Enduring Ones, suggest that the laborers saw themselves as part of something meaningful. These names show a sense of camaraderie and purpose, as if the workers were united in their devotion to the pharaoh and the gods. This spiritual motivation helped them endure the hard work of hauling 2.5-ton stones under the hot sun, knowing their efforts were for a divine cause. The religious significance of the pyramid extended beyond the workers to the entire society. The project was a national effort involving people from all levels: farmers, craftsmen, priests, and nobles. The pharaoh's divine status meant that building his tomb was a collective responsibility, a way for Egypt to show its strength and devotion. Priests likely played a role in blessing the construction site and performing rituals to ensure the god's favor. These rituals might have included offerings, prayers, or ceremonies to honor gods like Ra, the sun god, or Osiris, the god of the afterlife. The belief that the pyramid would help Khufu ascend to the heavens and maintain Ma'at gave the project a sense of urgency and importance, inspiring everyone to contribute. The cultural context of ancient Egypt also shaped the workers' motivation. In a society where community and cooperation were valued, working on the pyramid was a way to strengthen social bonds. The workers' village near Giza, with its bakeries, breweries, and living quarters, was a bustling community where people lived, ate, and worked together. This sense of shared purpose likely fostered loyalty and teamwork. The workers were not just individuals, but part of a larger effort, and their contributions were recognized. Some skilled workers even had their own tombs near the pyramid, decorated with inscriptions and offerings, showing that their role was honored. This cultural value of collective effort helped keep the workforce motivated, even during the long years of construction. Practical benefits also played a role in motivating the workers. While religion and culture were powerful drivers, the Egyptians ensured that workers were well treated, which made the project more appealing. Archaeological evidence from the workers' village shows that laborers were fed hearty meals, including bread, beer, and meat, which was a luxury in ancient Egypt. Animal bones found at the site suggest that cattle, sheep, and goats were slaughtered to feed the workforce, indicating that the workers were valued. Medical care was also available, as shown by skeletons with healed fractures, suggesting that injured workers were treated rather than discarded. These benefits, food, shelter, and care, made working on the pyramid a desirable opportunity, especially for farmers during the agricultural off-season when the Nile's floods made farming impossible. The seasonal nature of the workforce tied into both cultural and practical motivations. Many laborers were farmers who came to Giza during the flooding season, from July to November, when their fields were underwater. Working on the pyramid gave them a way to earn food and support their families during this time. The Egyptians organized the project around this cycle, bringing in thousands of seasonal workers to supplement the permanent skilled workforce. This system shows how the Egyptians blended practical needs with their cultural values, creating a workforce that was both motivated and efficient. The farmers likely saw their work as a way to serve their pharaoh and gods, while also securing their livelihoods, making it a win-win arrangement. The architects and overseers who planned and managed the project were also driven by cultural and religious ideals. These were educated men, often high-ranking officials or priests, who saw their role as a sacred duty. The chief architect of the Great Pyramid, possibly Imhotep's successor or someone like Hemiunu, Khufu's vizier, needed to ensure the pyramid was built to exact specifications. The pyramid's design, with its precise alignment to the cardinal points and its smooth sloping sides, was not just practical, but symbolic. It was meant to mirror the rays of the sun, connecting Khufu to Ra and ensuring his eternal life. The architect's attention to detail reflects their belief in the pyramid's spiritual purpose, motivating them to oversee every aspect of the construction with care. The scale of the project also reflects the cultural value the Egyptians placed on eternity and legacy. The pyramid was not just for Khufu, but for all of Egypt, a monument that would stand as a testament to the nation's power and devotion. The effort to build it, quarrying millions of stones, transporting granite, and organizing thousands of workers, was a collective act of faith. The Egyptians believed that their work would endure forever, just as the pharaoh's spirit would live on in the afterlife. This belief in permanence gave the project a sense of timeless importance, inspiring everyone to give their best. The cultural and religious motivation also helped the Egyptians overcome challenges. Building the pyramid was hard work, with risks like injuries, heat exhaustion, and logistical setbacks. Yet the belief that their efforts served a divine purpose kept the workers and leaders focused. The pyramid was a physical link between the earthly and divine worlds, and every stone placed was a step toward maintaining Ma'at. This shared goal created a sense of unity, turning a massive construction project into a spiritual mission. Even the seasonal workers, who might have joined for practical reasons, were part of this larger vision, contributing to something that would outlast their lifetimes. The cultural and religious motivation tied all the previous steps together: quarrying, organizing workers, using sledges and ramps, leveraging simple machines, and transporting granite. Each part of the process was infused with meaning, as the workers and leaders believed they were building something sacred. The Great Pyramid's completion, in about 10 to 20 years with millions of stones placed, shows how powerful this motivation was. It drove the Egyptians to achieve what seems impossible, creating a monument that still stands as a symbol of their faith and ingenuity. This final piece of the puzzle reveals why the Egyptians poured so much effort into the pyramid. It was not just a tomb, but a testament to their beliefs, their culture, and their unbreakable commitment to their pharaoh and their gods.